Today I want to talk about designing even larger applications. And this is actually a sequel to a talk I gave at JSConf Australia 2 years ago. And just like that last time, I want to kind of ground this talk in our career progression as software engineers. I think many of you in the audience would maybe call yourself a senior software engineer, or if you're not there yet, you aspire to be one, right? And so the way I would describe what it means to be a senior software engineer is that if someone comes to me and they say like, hey, Malte, do this project in this domain that you're already familiar with, you would say, yeah, that's actually something I know how to do. I don't need anyone else's help. I'm a senior person. I know how to do it. And then this was kind of the thesis of my last talk, was going beyond that. And with that software engineering lens, right, I'm not talking so much about people, but still you kind of transcend beyond yourself, right? It doesn't, you're only looking at solving problems yourself. You're looking at how can I, as a software engineer, anticipate how others do things and then design APIs accordingly so that they are more successful, right? So I think that is really beyond seniority. In this talk today, I want to go one level beyond that. I want to reach this stage where I can say, I can design software such that for large groups of engineers, the probability increases that the software that they produce is good. Now, there are three key words here. First of all, large groups of engineers. So if you work in a startup or like a 3-person company, then this talk may seem superfluous, boring, and extra, right? Like not something you care about. But I think many of you maybe work in maybe insurance companies, banks, or I don't know, anything, right? Like wherever you have a bunch of folks and multiple teams and you kind of need to coordinate stuff. Then I'm talking about probability. There's no security here, right? You can only try to set things up so that they probably work, but there's no guarantees. There's no silver bullets. Finally, I want to talk about good software. So this is not a product management talk, right? This talk will not help you write the right program, but it will help you write that program good. So what I mean is it being maintainable, high performance, having low bug density, being delivered on time, that type of stuff, right? These qualities that transcend the product aspect of software engineering. I want to clarify one more thing. I'm going to say stuff like frameworks, software infrastructure, other stuff like that all the time. I kind of treat them interchangeably. What I mean is kind of software that we are building that helps other people build better software. And what I would like you all to kind of put your mind into, like you're the person in your company who's responsible for kind of defining how people write software and then write the infrastructure, the software that they are using to write software, right? And when I say you build a framework, but I don't mean that you make your own React or Angular, right? Maybe that's actually the right way to do it, but it's not necessary, right? I think whenever you have a larger set of teams, you want to kind of standardize how they build applications, and that kind of puts a framework around how people build applications. So that's what I mean. And again, like think about you being the person who's responsible for this, and then this talk is about how you are successful at that job. And I'm going to talk about that in 3 chapters. The first one I call understanding the degree of uncertainty. Then we're going to learn how to solve all known problems. And then finally, we're going to learn about deploying change. Cool, let's dive right in with our friend Werner Heisenberg telling us that this is actually impossible. Understanding the degree of uncertainty. How sure are we that what's actually needed to be done is the thing that's needed to be done? That is absolutely key for software engineering. I'm going to talk about a technique to kind of understand how well we understand things. For that, we need to understand the problem space really well and understand how well we understand this. Sorry about the busy slides. These are just a few questions, basically. And the answers aren't even that important. But ask yourself, what is it in the existing infrastructure that your users, and your users are developers, what are they struggling with, and how are they struggling with it? What is the class of applications that folks will build using your work in kind of broad terms? What are the trends in the industry that influence what type of software is probably going to be written in the future, right? Because infrastructure is always for future software. Now, all of these, may sound like reading the tea leaves, but I think usually, if you've been doing this for a while, you actually might have answers. And so the key here is really you do this exercise to understand like how well can you answer this, right? That's really the key. Like if this is like really easy and you write it down and everything's clear, that's one side. Or the other side is like, no, I actually have no idea how to answer this question, right? I know nothing. Even more powerful than knowing what people want to do is what they don't want to do. Right? So these are non-goals. So what are non-goals? Non-goals aren't, you know, let's say you work for a manufacturing company and you don't need to like build an insurance piece of software, right? That's not a non-goal. That's ridiculous. Of course you don't want to do this, right? A non-goal is something that is actually super reasonable and even likely that you want to do it, but you know you don't want to do it, right? Like it's not a requirement. And so this might even be more difficult to answer. And again, like if you're able to answer these questions, that can be very powerful. And you know the degree of uncertainty is low. So why is uncertainty so important? When uncertainty is high, you're going to have to make trade-offs. You need to be flexible, right? You need to say, okay, I don't know whether I need to support this, so I better make it that it's possible, right? And whenever you're in that situation, you need to make trade-offs, right? So trade-offs are situations where you need to kind of square two things and make them both possible and probably end up with something that's not quite as awesome as something that only needed to do one of those two things. And the problem with trade-offs is that they make stuff difficult, and when you have unnecessary trade-offs, that really breaks software engineering. Like software engineering hates unnecessary trade-off, and it's the root of all evil. What is an example for this? Let's say in your company, you built this infrastructure for mobile apps, and you anticipate that, you know, maybe the salespeople, they have old crappy Android phones with low memory, and so you need to make it such that everything works in low memory situation. And so you design the software framework such that everyone's going and like needs to worry about memory and manage it and like all that stuff, right? And then it turns out your company goes and buys everyone a new phone, and that was completely for nothing, right? That's an unnecessary trade-off, but it's now much more difficult to write software in your system because it's in theory possible to run in these lower power devices. And so interestingly, this is a bit of a generalization of Donald Knuth's famous theorem, premature optimization is the root of all evil, right? So premature optimization is just a special case of an unnecessary trade-off, but it doesn't only have to be about performance. Every time you make your software do something that it doesn't need to do, you made an unnecessary trade-off. In the baseline of software design, that can be really, really fatal. Cool. So I think that's a bit of a web development conference, so I wanted to have one slide about web development. We have been doing web frameworks for a few years, right? Like it's been over 20 years now. And we actually understand how to build web frameworks really well. And if we don't, and if we do a bad job, it's our fault, right? It's not because we don't understand how to do this. Maybe we personally lack the experience, but we could do a really good job, right? So that's where the degree of uncertainty is actually quite low. Like we know how to build web apps. On the other hand, imagine it's 2015, and your manager comes and says, hey, I want you to build infrastructure for building deep learning. And you're like, well, I have never done this before. Like, no one in my company has ever done it before. There's like 3 blog posts about it. Then the degree of uncertainty is really high, right? And you won't be able to build infrastructure that's quite as nice, right? And so obviously, it's always going to be a range between like, we understand this really well, we don't understand it at all. But it's really important in software engineering that you can deal with uncertainty, right? There's always going to be something that you don't know, and then you need to be able to live in that space. So the reason why it's so important to understand the degree of uncertainty is because it allows us to then tailor the application to that uncertainty. And the way we do it is by tailoring the degree of abstraction. How abstract are we making stuff for our developers? And let me get something out of the way. Abstractions are awesome. You want to abstract everything as much as possible because abstractions make it really expressive. You can do exactly what you want. It's really fast. You don't have to write as much code. Everything's great, right? Except when that abstraction is the wrong abstraction, it gets in your way, right? You go and that abstraction doesn't do what you want, so you have to work around it. You have to like kind of beat to it and like make it do what you want, and everything is painful and terrible and not what you want, right? Like that's bad. So if you understand how well you understand the problem space, You can tailor the abstraction to that degree of uncertainty. And if you think, I don't actually understand that so well, you reduce the degree of abstraction, right? So that's really the key. How well do you understand what you need to do? If you don't understand it, reduce the degree of abstraction. By the way, do we agree that's her? Kind of. The random pictures. Anyway, cool. So kind of the summary here being, like, go take the time to understand how well you know things and then tailor stuff towards it. Again, it's always going to be the case that we have to deal with some uncertainty. So it's really useful that there's a set of techniques that's always good. We can solve all known problems in software engineering. I'm going to present 4 techniques to do this. Again, no matter how little you know, you always want to do these 4 things. The first one is optimizing iteration velocity. So what I mean with this is, developer and you hit save in your editor, how long does it take to go from that moment until you find out whether that was a good change, right? And there's, on the one hand, you have the super awesome hot code reloading as you type, everything updates on screen magic. And on the other hand, you like manually go to the console, kill your Java application server, recompile everything. It takes 20 minutes to start up, right? That's kind of the range, and I think probably many of you can feel with me, you've been somewhere between these two extremes. Now, that's obviously nice for something to be fast, but the reality is slow iteration cycles actually introduce trade-offs into our software design. If it takes a long time to find out that you made a mistake, mistakes are expensive. As a software designer, the professional thing to do is then to go and say, like, I have to design this API so that no one can ever get it wrong in their usage, right? Because if they get it wrong, it's so expensive, right? So how do you even do that nobody can misuse your API? It's really difficult, right? So if, on the other hand, everything's super fast, people can explore stuff, do things, figure things out because the cost of failure is so low, then you as a designer of that API can say, okay, maybe it's fine for people to do a bit more exploring here. So the message is, make iteration cycles fast. Very similar is the aspect of debuggability. So as a framework author, it's actually in your hand to control how hard it is to debug a system. Maybe you designed this like awesome, but like complex black box state machine that no one can figure out. It's just random things. They're sometimes the right ones, but sometimes not, but nobody knows why, right? Maybe your stack traces are super long and confuse people. Or maybe on the other side, you put in this like really sensible logging and tracing framework and people understand what's going on. They make a mistake, it's fine. They fix it, no problem. Similar to debuggability, you're in control of how testable your system is. Like maybe in your framework, it's really difficult to instantiate a system to the state where then someone goes and write a unit test, right? Or maybe it's really easy. And if it's easy to test the system, someone can go and like make sure what they did is right. And again, it's much easier to build in that system without understanding everything so well. Cool. We now had 3 topics that were more on the like software side of the world. The 4th topic for solving all known problems is slightly different. It's empathy. So as software engineers and software engineers who build software for software engineers, I mentioned this in my last talk, that's really empathy on easy mode, right? Like we can understand how other software engineers feel. We run ourselves. Much more likely that our own intuition is actually the right one than if we try to have empathy with like some more random person who we don't understand, like where we don't know their background, right? So that's really helpful and can do really well. Today I want to talk about a very special aspect of empathy. If you're the designer of a framework, you could build the perfect application with it, right? You know everything about it. You can get everything right. It's like very little code. Everything's perfect. But every other person who will ever use it will know less about it, right? And so think about what it means to not know everything about a piece of software, right? Think about how you can make an API robust towards not knowing everything. And the end result will be that people will just be much happier users of your application. Cool. So now we learned how to solve all known problems of software engineering. Let's go to the final chapter, which is deploying change. So this is really, really, really key. What I like to say that, software infrastructure that has no usage has no impact, which seems obvious, right? But it's so common in this field that people build ivory towers, right? Where you have a team and they go and they've built something awesome and they're really excited about it, and it being fun to build it was probably a reason why they did it, and then they come and say like, hey, I have a thing, and you're like, but that doesn't do what I want, right? And then everyone's sad, and they move on to the next ivory tower, right? So if you want to professionalize this, that is not the right way to do it, right? Getting your stuff adopted is everything, and it's a big part of your job. So much so that my first advice for how to get this right is actually totally in the realm of marketing, right? So software engineers, again, they're human beings. They want to work on stuff that's cool and that they heard about on Twitter and that's exciting, right? So it's fine to go and put the stuff they want in your infrastructure, right? Like they all like it more, and then they use it more, and everyone's happy. And if that's not the worst unnecessary trade-off in the world, then it's just okay, right? Cool. So that's more on the marketing side. Let's go to some bit more serious topic, which is that adopting software is easier if you can do incremental adoption. What this means is that instead of going like, hey, there's a new framework, rewrite everything from scratch in 2 years and hopefully it's good, to make incremental progress as you kind of work on it. Like have something after a month, have something after 2 months. Yeah, and I think basically even if you start with that major rewrite, at some point someone's going to say like, we need to have something in production now. Like we can't go on like this where we kind of do everything twice for like that whole period of time, right? So this is really something that if you want your stuff adopted, it's a key that you allow for incremental adoption. First technique here is really concrete. Just think about 2 different scenarios. The first is composition of your new framework code into legacy code. Let's say you haven't gotten around to like rewriting the app shell yet. Everything's still kind of the old way you did it. But the team comes and says, I'm going to build that new feature in the new framework. And so your framework is designed such that it can kind of live inside the old code base, right? That's composition into legacy code. And then there's the other side, which is composition of legacy code into your code base. Let's say you have this like super ultra customized business critical jQuery date picker, right? And people want to have it, right? And they want to keep it. And so you design your framework such that that jQuery thing, which probably violates all the assumptions you ever made, still works, right? That is composition of legacy code into your code base. Both of these things put trade-off pressure on your system because suddenly all these assumptions are no longer valid, but it's probably worth it because it allows people to incrementally adopt your software. Second technique I call temporary imperfection. So again, as a framework author, you probably have this like really idealized view of the world, like how people build software using your thing, and then it comes crashing down when people do incremental adoption, because not everything is great. So my advice would be to do the following. Write a lint rule using ESLint or something like that that identifies the old way of doing something, right? And then when there's code in the code base that is not the new way, you get an error message. Hopefully the error message also says, this is no longer the right way of doing it. Here are pointers to documentation how to do it, right? That's step 1. You have this lint rule. Step 2 is to then go and allow all existing violations, saying, okay, here's like 500 times where people do it wrong. It's all fine, right? Like these are all allowed. Now you're in a state where all new code has to comply with a new way of doing it. And this is really powerful because there might be all these engineers in your organization who haven't really read the email where they were told that they need to do something differently. They haven't come to your talk, right? But now they get an error message. And they are, okay, cool, I can do it a new way, right? It's really powerful. The other thing, and this is kind of an interesting insight, is that this allow list, which you probably check into your Git repository, it's a ledger of technical debt, right? Technical debt can be this like abstract concept that you know you have, and it's probably out there somewhere, but like really difficult to nail down where it is, right? With this allow list, like you literally know, in file X, line 15, there's my technical debt, right? And now you can pay it off. You can maybe have a team fix it where you say like 1 week we're just going to go at this list and like it's going to be gone after that week and we're all happy, right? So that's really, I think, it's a powerful way to think about like materializing technical debt as something that's like very concrete, just like debt on your bank account. You have this allow list. Cool. Next technique, which is key for getting my adoption, is to try for automated migration, right? It's not going to get you all the way, but it's pretty powerful. There's, for example, JS code shift from Facebook, where basically you kind of describe a pattern. This is the old way. This is the new way. You get from A to B. It's great. Again, this is possibly problematic, right? It puts trade-off pressure on your new API, because now the new API has to basically be happy with what was already in the code, but it can't really add new stuff in this mechanism. But it might be worth it because no one has to do that work manually. It's probably going to make people more happy than having to do everything by themselves. All right, moving on from these like more software-y things, let's talk a little bit more about humans. I think the one thing I would like to take everyone away from this talk is that when you're in this role of being like the person responsible for the software infrastructure, you always need a customer zero, right? That is what's that's the antidote to the ivory tower. The customer zero, what is going to happen is they're going to be the first customer who's going to use your thing and build a real product. And what you need to do is you need to go and sit with them, do pair programming or not, but at least be there and go build it with them, right? And this is before you declared you're done, right? Because now you can validate your assumption, you can find corner cases, and you can help, you can iterate on your framework until it's actually good. It might not have been there, right? Now, this first customer should not be a migration. It should be something you built from scratch. Because migrations are always going to be somewhat painful and long-winding, and why would you migrate to something that might not even be what you want yet, right? So you need quick feedback cycles at that point. But this will be really crucial to really ensure that what you're building is good. Another important piece of advice is, one of the ironic things is that if you never build anything with your thing, how do you even write the documentation for how to build something with it, right? Like how to write the onboarding doc to start from scratch if you've never done it, right? So if you go and have a customer zero and you work with them, that's the one-time chance you really get to write that onboarding doc, right? So don't miss it. Now, because this is all kind of designed for large organizations, there's going to be some organizational challenges with finding a customer zero, right? You might not find that team that's cool with working with this unproven, unstable, and probably not even good piece of framework, right? So what do you do to get that customer zero that's the right one for you? What I've found is that there's typically a team that likes to be on the cutting edge, right? One of the things you can pitch is to say, hey, you'll eventually have to migrate to this because that's the future. Why don't you want to be on the new thing already so you save that step, right? That could be very attractive for a team. And you can argue, because I'm going to sit with you, I'm going to actually make this framework to do what you want, right? You're privileged over any future user who will just have to kind of deal with what it is, because I'm going to realize, okay, it's not perfect for this use case, and I'm going to make it perfect, right? So this can be really powerful, even considering all the downsides. Now, maybe that doesn't work. In that case, your organization has to be mature enough to accept that there will have to be a mandate, right? There will have to be the time where you say, you actually have to use this, right? And that can be confusing for an organization. But it's so important because if you don't have it, the alternative is that the infrastructure team is just going to go and build ivory towers and everyone's unhappy, right? So it's still better to mandate that someone has to use your stuff, dogfood your stuff, than not doing it at all. All right, we have our first customer. Eventually, we'll have to do the first migration. And once again, it's actually your job to do this migration together with that team that actually wants to do it. So they're migrating to your framework. The reason why it's so key that you do this yourself is you have that point B, that's the future, to your framework, and you have the point A, that's where the team is, right? If you're not there, that team will go and say, hey, I need to go to point B, it's difficult, but I'll figure it out. They kind of take it as God-given, like, because they take your infrastructure as kind of being there, right? You can be like, I could make that one change here and it would be so much easier, and because I have this all in my head, I know what's possible to change. And because you're a lazy person, you're gonna make that migration really easy, and that is going to help everyone who comes after you have a much better time, right? Cool. These were the 3 things I wanted to talk about. Just let me summarize really quick. The first thing we need to do is we understand the problem space and then tailor our abstractions to that degree of uncertainty. Even if uncertainty is high, we want to solve all known problems. You might remember that. Increase iteration velocity, make debuggability great, testability great, and have empathy with your users. And then finally, nothing here matters if you don't focus on team adoption. Make your software likable, focus on incremental adoption, and get those customer and migration 0 folks. That's all I had today. Thank you very much.